Hello everybody, welcome back to Tech Code Analytics. And today I have designed a AI for math solving. Today the project that I am going to show you is basically a AI math solver using SymPy. Now here the idea is that I have built a simple AI math solver using Python and the SymPy library. And the program can solve equations, it can find derivatives, calculate the integrals, simplify the expressions. It can also compute the limits. So it is a very perfect code for beginner Python project for students, okay, who are interested in AI, mathematics and automations. So let's continue. I have been using Google Colab over here. If you want, you can make use of Google Colab. You can make use of VS Code, right? Just click on this connect and your Google Colab will get connected. Okay. Now, the first thing is that you have to basically import the SymPy library. So how to import the SymPy library? Import SymPy as sp. This is the library. Okay, now first define the symbols. So multiple declaration is possible in Python programming language. So symbols, let's declare the symbols. Okay, symbols. So I have been declaring variables like x, then y, then z. These are the three symbols, right? Let me write here uh, AI math solver. So this is our AI math solver. Okay, this is our AI math solver. Okay, AI math solver, right? This is our AI math solver. Just give a line, it looks good. Now, what are the modes basically available? The modes available. What are the modes? What are the modes available? What are the modes available? The modes available will be number one for solving equations. Okay, now number two, it will be for derivatives. Okay, solving derivatives. Number three, it will be for integral. Okay, I'll just copy paste this. It will be for integral, right? And next I will keep it for simplify, then limit, and the last one is going to be quit. So let me just change the numbers. So 5 and 6. So the first one is for solving equations, the second for derivative, and the next one will be for integral and simplify. Then we are going to have a limit. Okay, we are going to have a limit, then we will have quit. Okay, now let's run and see. I hope we don't have any syntax mistake. If it doesn't give any error, so no syntax mistake. Okay, so perfect till here, perfect. Now what I will do, I'm just going to run a while loop. Okay, while loop means it will continue until you click on quit. Okay, and choice equal to input. I will just give an input. Okay, in a new line, I will write here choose the mode. Choose the mode. Okay, if your choice is equal to suppose 6, okay, then you are going to print goodbye, goodbye. Okay, and your control will break over here. Okay, right, the control will break. Okay, now let's write the expression in the else part. If you don't choose point number 6, then what? Then it will prompt you to enter the math expressions. It will prompt you to enter the math expression. Okay, now in try block, this is basically exception handling block. I am going to write the expression. I'm going to write the expression. Okay, so the expression will be sp dot simplify. Okay, and you just pass the expression, and if the choice is equal to 1, okay, if the choice is equal to 1, then what will be the result? The result will be sp dot solve, expression, and pass the variable. Okay, pass the variable. After that you simply print the solution. You print the solution. Now what is the solution? The solution is the result itself. So perfect, it's done. So we have completed the first part, that if your choice is equal to 1, then it's going to print the solve the expression, and it's going to print the result. Okay, elif elif if your choice if your choice is equal to suppose 2, if your choice is equal to 2, then I will just copy this. I'll just copy this. Just try to maintain the indentation. Okay, maintain the indentation. So in result we are going to solve for, I think, diff. Okay, diff, because your choice is second one is actually for derivative. Okay, derivative. So sp dot diff, you pass the expression as the parameter, then you pass x, and here you are going to print for derivative. Okay, derivative, derivative. Okay, I just made a spelling mistake. Okay, now that's it. Just copy this else if part once again. Copy this else if part, paste it over here. Try to manage the indentation. Now if your choice is equal to 3, okay, so this is actually for integration, right? Integral. So inte great integrate. Okay, integrate. Okay, integrate. So let's find the integral. Okay, integral. If your choice is equal to 3, okay, integral. Now we have already copy pasted the else if part. So now this time if your choice is equal to 4, right? If your choice is equal to 4, so what is going to be the next? It is going to be sp dot simplify. We have passed the expression. You don't need to pass x over here once again. Okay, right? So this is basically for simplified. So this is basically for simplified. Okay, simplified. Now again, just copy paste the else part. Okay, so if your choice is equal to 5, okay, if your choice is equal to 5, then do one thing. This is actually for a limit. Okay, this is for limit, right? Limit. So what you have to do here, you have to do one thing. You have to do one thing for limit point. You have to take a float input, and input inside the float input, it's going to find a limit as x approaches. As x approaches, then you have to go for the result, and the result will be sp dot limit, and it will be expressions. It will be expression, then x, then limit point. Okay, then limit point as we have defined above. Okay, now you print the result. So the result will be limit. Okay, now since this part is done, then you have to write the else part. In the else part, it will be printed like invalid choice. Okay, invalid choice. And we are getting an error on this try block. The reason is that with try you have to give one except block. Okay, except exception is the base class. Just create an object of e, and you print here the error, right? Print the error, right? Whatever the error is, you just print it. So perfect. So here we have basically done. We are basically completed. Now let's run this particular program. So you can see it is telling the choice. So let's first enter 6. So it's telling goodbye. Very good. Now let's test our application. So let's run this particular application. I will solve the equation first. So I will choose the mode as 1. Now enter math expressions. Enter math expressions. So math expression x, suppose square plus 5 multiplied by x plus 10. If you hit enter, okay, so see, this is basically the solution it is giving you. It is giving you the solution, right? Now let's choose the option S2. Choose the option S2 for derivative like 3 multiplied by x square plus 2. Hit enter. So it is giving you the derivative, right? It is giving you the derivative for integral mode. Let's choose 3. Okay, so let's enter the expression, a very simplified expression. So see, it's giving you the output. Okay, now let's choose the mode as 4 and let's give the expression. Okay, expression something like this, like x square plus 2 multiplied by x plus 1. Okay, so this is basically the simplified form. Okay, now for limit, let's choose 5, and here let's enter the expression like sine of x upon x, sine of x upon x. So you will get the output as limit as x approaches 0. Okay, so limit 1. Okay, so you can see how we are basically choosing the modes and we are giving the outputs. Okay, we're getting the outputs basically. Okay, now at the end just choose the mode as 6 and that's it, the program is completed.